In today's video, we will learn about the discovery of proton, that is through the anode ray experiment. So, we have seen the presence of negatively charged particle in an atom, that is known as the electron, and we know that an atom is a neutral particle, right? That's why there must be equal amount of positive charge in an atom, right? So that's why in year of 1886, Goldstein performed the experiment to find the positively charged particle by the discharge tube experiment. Here he took a perforated cathode tube. That means you can see here the electrode, that is the cathode, is perforated. That means it has small pores inside it. So what happens on passing high electric discharge through this tube? So we see some fluorescence or some light patches on this screen, that is the zinc sulfide screen that is present behind the cathode electrode. That shows that something is passing from this anode that is going towards this screen, and this is passing due to the perforated cathode, right? So what happens, these rays were called the anode rays because they are arising from the anode electrode, right? And these rays were able to penetrate through the perforated cathode and make the fluorescence screen, and these rays were also called the canal rays as they pass through the canals, that is the perforated or the holes present on the cathode, right? Now these were also called the positively charged rays because they carry positive charge and they are arising from the positively charged anode. That's why they are called the positive charged rays. Now talking about the origin of anode rays. So anode rays are produced when high speed electrons of the cathode ray moving towards the anode collide with the gaseous atom, knocking out the electrons from them and producing positively charged particle, and this positively charged particle move towards the cathode because positive charge always attract towards the negative charge cathode, right? In the form of anode rays. Right. Now talking about what will be the mass of proton. So the charge to mass ratio, that is the E by M ratio of proton, is found to be 9.58 into 10 raised to power 4 coulomb per gram. So here by this we can easily found the mass of proton by giving the charge upon the ratio, that gives us the mass of proton. That comes out to be 1.67 into 10 raised to power minus 24 grams or 1.67 into 10 raised to power minus 27 kilograms. And it may be pointed out that if any gases except hydrogen is taken into the discharge tube, the mass of positively charged particle were found to be whole multiple of the mass of proton, and thus the proton is a subatomic particle and proton is present in all the atoms that have the same mass of proton in all kind of atoms. So I hope this topic is now clear to you. Thank you.